It's time now to code our player so that we can actually control them using the arrow keys and our mouse to look around. Now, this is going to be a lot of code, but keep in mind that this tutorial series is not about how to code a first-person character controller. So a lot of this I'm just going to be giving to you. I'll try to explain a little bit here and there so you can actually customize the settings for your character controller, but there's a lot of methods in here that you don't need to understand. Our goal is to make a game that's kind of like volleyball. Okay, so let's get into it. So in our scripts folder, go ahead and right click and create a new C# script, and we're going to call this player. On your player game object, let it compile. There we go. Go ahead and add the player component and go ahead and double click and open it up. So we need a reference to our character controller component, and I'm going to call it _controller. We need a reference to the camera as well, so I'm going to call that camera main cam. Now we need a few things, so I'm going to make a attribute called a header, and then in parentheses I'm going to call this character settings. So I'm going to create a private float called speed, and we'll set our speed, which will be like our movement speed, to maybe 7.5, and this will be serialized, so we can change that in the inspector. We also want a serialized variable. This will be our gravity, so like how fast we fall, and I'm going to put that to 15.0f. Let's do another serialized field variable. This will be our private float jump. Like how fast we jump, and I'm gonna set that equal to 5 for now. And lastly, let's do a serialized field for private vector 3. We need a starting position, right? So that if we run off the map, just like our volleyball, if we fall off, we can respawn somewhere. Okay, so these are all of our character settings that we'll be having. We also will be having a camera setting. So I'm gonna create another header, camera settings, and one more serialized variable. We will call this a private float camera sensitivity, perhaps, and I'm going to set that equal to 2 by default. So if you hit play or hit save on your script real quick and hop back into Unity, we should see, there we go. So on our player script, we now have these character settings, our speed, gravity, jump, and our starting position, and our camera settings, like how sensitive our camera is when we're looking around. Cool. None of these variables do anything yet because we've just made them, we're not using them, but this is primarily what you'll be interacting with to change how your character moves so that you have a character controller that feels good to use. So let's actually go ahead real quick and set our starting position. I'm at 0 to -13. That sounds good to me. 0 to -13. Cool. Let's go into our player script and let's start. First things first, let's grab references to our components. So I have my controller component, and that's going to equal get component, character controller. We'll null check. Awesome. Now that we have our controller, let's do the same thing for our main camera. Main cam equals, and there's a shortcut for this. We can just say camera.main. So that's the first camera in your hierarchy that has the tag main camera. Okay, and to show you what I mean by camera.main, go ahead and hop into Unity real quick. And the main camera that's childed to our player, look at the tag. It's tagged main camera. So if for some reason your camera's not being grabbed, just double check that it is tagged. It's time to do some stuff with our cursor. So we're going to be using our mouse to look around, to look left and right. So we actually want our cursor to disappear. So the first thing we're going to control is the exit out of it. So let's say if we hit escape, we can get our cursor back. So I'm going to say if input.get key down, key code dot escape. If we hit escape, our cursor dot lock state is going to equal cursor lock mode dot none. So that's like normal. That's like saying we can see our cursor just like how we normally do. So now in start, at the very beginning, now that we have an escape, because this is very important. So now at the beginning, we need to add a cursor dot lock state equals cursor lock mode dot locked. All right, now hit save. When you go back into Unity, my cursor is normal. I can move around. I'm going to hit play. Cursor's still normal, but the moment I click into view, my cursor's now gone. It's gone. I can hit escape, and now my cursor is back. Okay, so we know that that is working. There are 3 main methods that we'll be checking all the time. Void, check for out of bounds. So we will also have void move. These will be all our movement controls, and we will have void look, right? So our move is like our arrow keys. Our look is using our mouse to look around. So we can isolate these 3. If there's ever a problem, you know exactly where to look. So in update, Let's put all three. We're gonna go right here. We're gonna say check for out of bounds, move, and look. And it doesn't really matter the order, but I guess if I cared, I could put check for out of bounds right after move, but like it's fine. Okay, now that we have these methods and they're constantly being called in update, let's fill in our movement. First, we need to check if we're on the ground, right? So if controller.isGrounded equals true, then we can actually move, because we shouldn't be able to just fly around in the sky. We should only be able to move if we're on the ground. So we're gonna grab a horizontal input, and that's gonna equal our input.getAxis horizontal. We also need our vertical input, so float vertical input equals input.getAxis vertical. What these are, the horizontal input is your A and D keys or your left and right arrows. All four of them are mapped to this axis. Your vertical input, it's the same thing. It's W and S, and it's your up and down arrows. Now that we have these horizontal and vertical keys, we can calculate the direction for us to move, right? So that would be a vector 3 dir. Just gonna call it dir. You know its direction. And that's gonna equal a new vector 3. For the X, that's gonna be horizontal input. For the Y, it's gonna be 0. And for the Z, it's going to be vertical input, right? Because this Y here, this will be our jumping eventually, but for just moving around, it can be 0. We have to do a thing to transform the direction so that we actually move wherever we're looking. The direction is going to pass through this method called transform.transformDirection, and we're just going to put our dir in there. You don't have to know what that means, but if you take this line out, if you just comment it out and try it again without it, you'll see what a difference this does. And lastly, let's go ahead and calculate our jump. So if input.getKeyDown, and we're going to call it keyCode.space, or whatever key you want to press to jump, we're going to say dir.y equals jump. So whatever we put up here as our jump height, instead of 0, it's going to be set to that jump real quick. Now we need to calculate gravity, right? We need to actually be able to fall. So this is all happening when we are grounded, when we're on the floor. So gravity doesn't happen inside this if statement right here. Gravity happens below it, one line lower. And the thing is, we need to change our dir, our direction. But our direction only exists within this if statement because I made it locally, just like I made it right here. So right here on this line, I can't say dir.y because it doesn't exist. So what we need to do up at the very top is we need to just make a vector 3 dir. Oh yeah, I'm gonna make it a private vector 3 dir. There you go. And now that you have that, you can scroll down, delete the vector 3 reference from there, and now this dir variable is global, so I can use it down here to calculate gravity. So I'm going to say dir.y minus equals our gravity times time.delta time. And finally, after all these calculations, we can say controller.move. We're going to pass in our direction. We're going to multiply that by our speed and multiply that by time.delta time. Whew, okay. Take a second. If you need this code, here's everything in our movement function right here. Save your script, hop into Unity, and when we hit play, I can move. It's hard to see because I can't actually control my camera at all, right? So I can just move cardinally. I can jump. Perfect. We've just completed move. Let's check for out of bounds real quick. We're going to do the same thing we did for our volleyball. If transform.position.y is less than, I don't know, -10. You know this component that our player has, this character controller component? One thing that I've learned from programming this is it really doesn't like being teleported. It does not like it if you just tell a character to spawn somewhere else. So in order for us to respawn, which is what we're trying to do with check for out of bounds, we need to turn that controller component off. So we're going to say controller.enabled equals false. Now we can say transform.position equals our starting position. And then we can turn the controller back on. Controller.enabled equals true. Okay, now that we have that, hop back in, make sure you've saved your script, hit play, and my goal is to just fall off the edge and see if I respawn. Bye-bye. Yay, okay, and I respawn perfectly. Bye-bye. Sweet, okay. So if we're looking in our update loop, our last method we need is our look method that uses our camera. So in our look method, very similar to how we just did it in our move method, instead of getting the keys up, down, left, right, WASD, we want to get our position of our mouse. So I'm going to say float mouse X, and that will equal the input.getAxis mouse X. do the same thing for the Y. Now that we have X and Y, we will be wanting to look left and right, up and down. When we're looking left and right, we're actually moving our player. When we're looking up and down, we're moving the camera, right? Because we don't want like our physical body of our player to rotate down. We just want the camera to look down. Whereas when we look left and right, we do want the physical body to turn left and right. So let's start with left and right. We are going to, it's dealing with our rotation. So we're going to cache our current rotation in a variable, and we're going to set that equal to the transform.local Euler angles. Oh, and that's a vector 3. And we're going to take our current rotation dot y, since that is the up and down axis, right? That's y is up and down. So when you rotate y, we'll be turning left and right. So current rotation dot y is going to plus equal our mouse x times, didn't we have a camera sensitivity? Yes, that's what we made earlier. Cool. And now that we've done that calculation, we're going to set our transform.local rotation equal to this method called quaternion.angle axis. We're going to pass in our current rotation.y, and the axis we're rotating around is the y-axis, so that is vector 3.up. You can save your script, hop back into Unity, and when you hit play, I can now move my camera left and right. I can't look up and down, but I can move left and right, and I can move in whatever direction I'm looking. Yay, I can actually control it. Perfect. For our rotation X, right, since we're rotating now, the X of our camera rotating means that we can look up and down, right? Because X is the axis that's left and right. So if you rotate that, you're looking up and down, if that makes sense. I'm actually going to cache this as a variable up at the top. So I'm going to call it a private float rotation X. Yeah. And the reason I'm caching this is because I want to make sure that it persists from frame to frame, that I'm not just going to make this float, set it to 0. Like it might have some weird behavior if I just create it like how this rotation is created each time. Let's say our rotation X minus equals, you can try plus equals. I did minus equals, so it's inverted, but you can do plus equals. Like try each different one and see what you like better. Look up and down is controlled by our mouse Y, and we're going to times that by our camera sensitivity. We also want to clamp it so that we don't like look all the way around forever and ever and ever. That'd be kind of crazy. So we're going to say rotation X equal mathf.clamp, where we're going to be clamping the value of rotation X. The next thing is the minimum, so I'm going to say negative 30f, and the maximum will be 30, like degrees, I guess. Now that we've calculated that, let's take our main cam.transform.local Euler angles, and let's apply that. So we're going to say that equals a new vector 3. The X is rotation X, the Y is 0, and the Z is 0. Okay, and now when I click in, I can look up, but not too far up. I can look down, but not too far down. I can look all the way around. If you do want to be able to look up more, you can go into boop, boop, boop down here, this negative 30, 30. We could make that, let's say negative 30 because that's looking down. Let's say 60 on the positive. And now take a look. Now when I click in, I can look up much higher. I can still only look down like at my feet, right? And I can look up to like there. That's pretty good. And from here, our character controller is complete. So give yourself a round of applause. Yay! Now, when you look on your player, these settings you can change. So if you want your speed to be like 15, click 15, go back into your game, and now as you move, you're gonna notice you're crazy fast. You could set your jump height to be 30, and now you jump crazy high up. Where's the ground? There's the ground. Okay, cool. So you can mess around with those numbers. The numbers I gave, 7.5, 15, and 5 were numbers that I like. You can change them. The things I do like to mess with is camera sensitivity. That's how quickly you can look around. But yay, this is our camera controller all the way done. Yay. In the next one, we're actually going to code the UI so that we can get points. That one's really simple to program. So that will leave us with the final part to code the ball, so we can actually push the ball around. So in the next one, we'll be doing UI. See you then.